So, good evening, guys. This side Panshujan. I think am I audible and visible both? So, so talking about myself a little bit, I am this side Panshujan, and I am the member of the technical team of Codechef ADGITM Chapter. And talking about my achievement, I am the four-star coder on Codechef, and uh, and also have the idea of open source, and and being a top contributor in Gulfscript Winter contribution and also in the Gulfscript Summer of Code, and currently working as the front-end developer intern in Omicron Technologies. So, not wasting the time, directly jump over to the question. As we know that the today's question is minimum number of jumps to reach the end of the array. So starting from the problem statement, if we read the problem statement, it is goes like given an array of n integers named array name ARR, where each element represents the max number of steps that can be made forward from that element. Find the minimum number of jumps to reach the end of the array starting from the first element. If element is 0, we cannot move through that element. This is simple thing that if any element is in the array is 0, we can't proceed, or we can say we can't make the next step, because in that case we don't have the case of jump, because element is 0. We uh, we uh, we can't proceed further. And and talking about the note, as there is that we have to return -1 if we can't reach the end of the array. So so directly moving over the pictorial. So so now I will be explaining. uh, Give me 2 minutes, I am sharing my screen. Okay. So 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 please, you all read the puncture once, so that you can you will get an idea what is going on with the question of minimum number of jumps. I am giving you the 1 to 2 minutes to read the question. So now we proceed to the further explanation of the question. So as we know as our question said, that we have to start from the first index, and we have to reach the last index of the array in minimum number of jumps, or uh, and the jumps which we made are defined in the way that the value stored at that index will define that from that index how many jumps we can make. Like, if we take an example of the first index only, we have the value 2. So we can make the two jumps from this index. Like, we can jump it here, then here. Means from this index we can reach this till this index only, not further that, because there is a restriction about the value which is given to the index. Till that value, or we can say uh, that many of jumps we can make. So talking about the approaches, there are two approaches to solve this question. First is greedy approach. Let me write the uh, let me denote the greedy as G, and second is DP. Talking about their time of complexities, greedy approach will take O of n time complexity, and talking about DP, it will take O of n square complexity, and the space complexity of greedy one is O of 1. Here is the point to be noted. Whenever you will get the space complexity of O1, you will keep in mind that you don't have to use any other data structure or or uh, uh, or we can say the any other container to store the values of the array, or we say that we don't have to use any other data structure to solve that question, because if we use any other data structure to storing the values or to manipulating the values, so in that case our space complexity will not be of 1, it can be of n square. It it solely depends on the data structure which we are using. So keep in mind that whenever we get the space complexity of O1, we have to solve the question using the variable, uh, mainly the variables. So, and talking about the DP1, the space complexity of DP1 is of n. As we take the array to solve this question, that's why the space complexity of DP1 is O of n. Here we will discuss the optimized one, the greedy one. Let's move to the explanation. Let's me clear the okay. Let's again define the array. 2, 5. So, our when the word greedy come into our mind, the main the intuition which which would come in our mind is like that: greedy means we have to take the maximum thing or the minimum thing. So we have to think in that way only, that as we know that we are using greedy approach. So in this case, what thing we can take as maximum, did will think about it, then then I will give the beau- beautiful thing to think about it, so that you can imagine this question very easily. So we will think about this question like ladder and stairs. Here ladder is defined as the value that is given in that index. So we can say that the length of the ladder is defined like this: that if the value is 2, the length of the ladder is of length 2, means using that ladder we can jump, or we can say we can cover the distance of 2 unit, or we can say the 2 indexes, and we have the 2 stairs, so that we can walk on that ladder. Now, for solving this question, we will maintain 3 variables. As I said that we have to solve this question in of one time complexity. The variables which we maintain are max, ladder reach, MLR. Second will be stairs. As I explained that the stairs are the steps, or we can say the steps which are on the ladder, which we have to uh, uh, follow till the end of the ladder. Let the stairs, and last jump. So as we know that we have to start with the first index, so we will denote MLR and stairs as the first index. As we know that we have always have to start from first index, as it is stated in the question. And we will define jump as the one, because we have made the first jump o- over the first uh, over the first ladder, because our first ladder is starting from the first index only. So we have made the first jump to uh, to, uh, uh, to the journey to reaching the end. So now, what this MLR means? MLR means that using that ladder, using that ladder till which position, or we can say till which index we can reach, using that ladder. Example, as I said that here MLR is 2. So here we can reach till index 2 if we use the a, a of zeroth ladder. So here means, so here we can see that this is index 0, index 1, and index 2. Yes, it is solely great that if we are using the zeroth element ladder, we can reach till second second element of the array. In this, we have to store that when we iterate further in the array, in this variable, we have to store uh, that uh, that if we use that, let's assume if we jump on this index, so we have to check that if we use this ladder, we can we can reach to the index which we are reaching previously by using that ladder. It is greater or smaller. If it is greater, example, if we use this ladder, so here the index of this element is I, plus the ladder length is of 5. I mean, sorry, not 5. The ladder length is of a of I. So here the index which we can reach is 1 plus 5. So index is 6. Yes, it is greater than the index which we can reach using the previous ladder. So we update our MLR with 6. Now our question is, why we are not making choosing our maximum ladder? As we say that we are following the greedy approach, we have to take the maximum thing, or and and here we can take the maximum things as the maximum ladder. So here, so so here our question arises, why we are not taking maximum ladder as per the length of the ladder. Let me take another example to explain more easily. 3, 5, 5, 2, 1. In this case, we can see that two same length ladder are present in this array. And and if we go on with the approach which we are discussing further, like if we if we define our maximum ladder on the basis of the ladder length, or we can say the values which are storing at the index. In this case, it will fail, because we can't differentiate between the indexes. If we if we choose this, in this case it will be fine. Let's assume there are 5 more elements. 1, 2, 3. Let's assume there are five elements, like 2, 4, 7, 3, and 1. So if if we choose this one, this will be not optimal, because if we choose this one, we can reach one index more further. you can you can understand that, that's why only we are using that u- using that ladder till which position we can reach. In this way we can encounter this condition, or we can say encounter this edge case, because if we get the same length of ladder, we can't distinguish, or we can say we can't choose the optimal way to uh, to reach the end, or we can say that to reach the maximum position. So so here, so now we will define our MLR, maximum ladder reach by this, not by this, not by A of I, because if we get the same element, it will be fail. So let's give a run through to get more clear idea about this approach. So here we will define our MLR. Sorry for that. MLR stair, just define stair as S and jump as J. And as I said in starting, we have to define our MLR as 2, as the first index value, A of 0. Here 2. Stairs will be also be 2, and jump as 1, because we have made our first jump on jumping the first index ladder. So here we can see that now a loop will be run till I equal to 1 till n, and let's give a run through. As we move further, our stairs will be decreased, because we have taken the next step, or we can say uh, we are start covering our ladder, which is starting from this to this, and these are the stairs. As we have jumped to this stair. Now we check, is if we use this ladder, we can is we can reach uh, the index maximum than the ladder previously we are reaching, like. So here our formula is 1 is the index from which we are starting our ladder, and 7 the length of ladder, it is 8. Yes, it is greater than the previous one, so we update our MLR to 8. MLR to 8. Now, okay, now we move on other stair. Our stair on 0. Now we again check it. If we use this ladder, it is uh, we can reach uh, the further index which we are reaching using the previous ladder. Is that 1 plus 3, it is equal to 4. No, we are, if we use this ladder, we are not reaching the index which is greater than the previous one, MLR, which we are reaching using the previous ladder. So we can't, so we don't update our MLR. And now when our stair gone 0, so this is the case when we have to jump to the another ladder, the ladder which we are storing in MLR, because this is the optimal, or we can say it is the maximum length ladder which we are storing. So now, so now we have to update our stairs, and we have to update our stairs in the case that if if our I if our I is less than the MLR, means means uh, means that we can directly jump to the index till the MLR, means we have the stairs left to cover in our maximum length ladder. Example, if if, if I take the example of this only, we are reaching till 8th, and we have the index till 4 only. So here, one. So so if our I, let's assume our I is here, and we can reach till here, as we have the stairs, we have the stairs left here to cover this distance. So we can update our our stairs like mlr. Mlr is the max index which we can reach using that ladder, minus I. I is the index which we have covered using the previous ladders. If this is the condition, remember this. If I is less than MLR, then only we can define our stress like this. And if our I is greater than equal to MLR, if our I is greater than equal to MLR, this is the case, means our I is here, I is here, assume that I is here, and our ladder is ending here only. So this means that we can't reach I. If we can't reach I, we also can't reach the end of the index. So in this case, we have to return -1, as we see in the problem statement, that if we have to return -1, as we see in the problem statement, that it is stated that uh, that if we can't reach the last index, so we have to return -1. So so in this, if the if I is greater than the MLR, in that case we have to return -1. So now let's iterate our array again. Let's see, we erase this all. We are here. As the stair gone 0, we have to define 8, and our I is 2 in this, as we say. So 8 minus 2 equal to 6. So we have the 6 stair left, or we can say we have the 6 stair to iterate, and we have to increase our jump to 2, as we know that that uh, our previous ladder is ended, and we have to jump to the next next ladder. So again, let's clear this. Our ladder started from here as like this. This, this, and this. Now we iterate again. We jump this from here. Let's share v 5, and we check here also that we also update MLR, because we uh, we don't reach our end of the array. So till then, uh, we uh, we can't stop storing our maximum ladder reach. So here we can see that here the index is 3 plus 4, 7. It is greater than this, no, so we can't update. Let's move on to further. Stair gone 4. So here we also check. We check if 3 plus 4 equal to 7. It is greater than MLR? No. So we can't update. But 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 we but we reach our l- end of the array. So when we reach, when I is equal to n minus 1, and I is equal to n minus 1, we return our jump in which our answer is storing. We return our jump. So this is the full iteration. How we iterate our array, how the values in the MLR stairs and jump in changing. What are the condition in stairs? Means that if if I is less than the MLR, we can directly jump to the max index, or we can say the we change the stairs like MLR minus I is the index which we have covered, and if the I is greater than MLR, in that case we have to turn minus 1, because we not able to reach the I till I. So how we can reach till end of the array? So in that case we have to return minus 1. Now we have to now I would like to discuss two edge cases. First edge case is which first edge case is if our n is the length of the array, is less than equal to 1, means it is the case when we have the only one element or zero element. Like let's take example, if we have the one element. So this is our starting index and last index both. So we have to make zero jump to reach our last index. So we have to handle this case. And our second edge case is if our sorry if if a of 0, if a of 0 if a of 0 is equal to 0, in that case we have to return minus 1, because we can't proceed further. If our first element is 0, we can't made our we can't even start our ladder. So these two are the edge cases which we have to handle. So now moving over towards the code, let's make the folder. I think it's visible. Let's increase some font. Okay, let's write our code. Let's first take the size of the array, define our array. Now we take array as the input, and we define our function which calculate our minimum jump, and pass array and size of the array as the argument. Value of int type int n. Now, now we handle our edge cases first. If n is less than equal to 1, we have to return 0. And if a of 0 equal to 0, we have to return minus 1 as we can't reach our last index. Now we define our variable which is MLR. MLR is max ladder reach, which we define as the array of 0. Second is our stairs. We define as this. Now now we define our jumps as we taken our first jump to jump will be defined as the equal to 1. Now we iterate our array starting from first index because we have jumped over to 0 index already. Now we will define now now we will calculate our maximum ladder reach and we and we define our maximum ladder reach as the index which we can reach using that ladder. Now we keep on moving on the ladder which we are, and if our stairs equal to 0, now we have to check two conditions. First is if our I is greater than equal to maximum ladder reach. If I, means we can't reach I using our ladder. So in that case we have to return minus 1 because if we if we're not able to reach I, we also not able to reach the end. Otherwise, we have to update our stairs as maximum ladder reach minus I. I is the index we covered, and maximum ladder reach the maximum index which we can reach using that ladder. Now, the condition in which we have to return answer is I equal to n minus 1. In this case, we return our jump. And if this loop not uh, return our answer, so at last we have to return minus 1. Means in that case only also we not able to reach our end. So our uh, let's check is this code is right or not. Let's take the input same as we have taken. No, it is the 5 2 5 3. Let's see the random 2 4 6, and the answer of this answer will be 2. Let's check. It's failed. Let's check what's the problem with the code. It is returning 1. AF 0, stair 0, jump 1. Our base case is correct. Uh, let's check again. I think there is not so problem. What's the problem here? Why this? Why it's not returning correct answer? Oh, I got. We are not increasing our jumps here. Sorry. As the shares become zero, we have to increase our jump because we are jumping towards the next ladder. Now the answer will be correct. 5, 2, 5, 4, 6, 8, 6, 2, and output will be 2. Now this you can see that this test case will be passed. Now try to submit this solution in GFG and change this ARR to A. Let's compile. It's configured output. Now try to submit. Now you can see that this is the correct answer. Now I will show some twist. If we check this, if we check this condition first, now I will try to submit. Now see. So here our test case failed. And why? Let's discuss this also. Sorry. Let's discuss this also. So here, if we check our A of 0 is 0 at first, and the and and if the array which we given as the input is as the is only given our one element 0, so in that case we have to return 0, not minus 1, because our starting index and ending index is same. And and when we are checking our a of 0 equal to 0 at first, and 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 this case is coming, so in this case it will returning minus 1, but it will have to return 0. So to encounter this we have to check our this condition at first, so that if if any element uh, i- if the array of size 1 is encounter, it will always run the it will first check the length, and then it will check if the first element of the array is 0 or not. So by this our question, minimum number of jumps to reach the end is solved. Thank you for listening me. Any questions? Thank you guys for listening.